Hello and welcome to opener number 2 in Unit 4. We're going to solve a few equations here today, and some interesting things are going to happen. So our task is to find the value of x for which the rectangle is a square, and what that means, of course, is that this side must be the same length as this side, so this quantity must be equal to this quantity. So I'm going to write this equation, 2x minus 2 over 3 is equal to 2/3 times the quantity x plus 9. Now, there are a lot of different ways you could go about solving this equation. I think the most straightforward way is to realize that this side is being divided by 3, and this side is being multiplied by 2/3, which is the fact that there's a 3 in the denominator here shows a division by 3 as well. So the way you can undo division by 3 is, of course, to multiply this side by 3. And then we'll also multiply this side by 3, since if we did it to one side, we have to do it to the other side. So 3 divided by 3 is just 1, so these cancel out, and the same thing happens on the other side. And I'm just left with 2x minus 2 equals 2 times the quantity x plus 9. And next I'm just going to go ahead and distribute that out and get 2x minus 2 x plus 9. Now, if you were really paying attention, you may have noticed that on the left-hand side of the equation, we've got a 2x. And on the right-hand side of the equation, we also have a 2x. Now, if we're going to take this 2x and subtract 2 from it, it doesn't seem possible that we could take that very same 2x over here and add 9 to it, and really end up getting the same number. So if you were paying attention, you might already be thinking to yourself, wait a minute, something here isn't right, this isn't possible. But let's say that you aren't really paying that close of attention, and you just sort of keep going with your algebra. So perhaps you say, well, I'd like to get all of the variables on both sides, on the same side, so I'm going to subtract 2x on this side to cancel that out. On this side, but wait a minute, when you subtract 2x on this side, you just end up with 0 again. These also cancel out, and you end up with this equation that says that negative 2 is equal to 9. Well, I hope I don't have to tell you that that is, of course, a false equation. What that means, and if we go back to sort of the highlighting that I did up here, what that means is that this is impossible. The equation I wrote at the very beginning here up at the top cannot be solved. There is no way to make this equation true. So the way we write that is, you can just write the words no real solution. Another thing you can do is you can write the empty set, which means that the set of numbers that satisfy the equation is empty. There's nothing in that set. And you can write the empty set either as 2 brackets with nothing in between them, or, I don't know what the technical term for this symbol is, but a 0 with a line through it is also the empty set. So we tried to solve our equation. We did all legal algebra moves throughout. We ended up with a false equation with no variables left, and that meant we had no real solution. Okay, let's take a look at the second question then, or the second problem. Again, if we want this thing to be a square, we're just going to set the 2 expressions equal to each other. And what I like to do to handle this negative sign in front of this set of parentheses is pretend that there's a 1 here and distribute a negative 1 into the parentheses. So then I end up with 3x minus negative 1 times x, which of course is just minus x, and then negative 1 times negative 5 will give me plus 5, and that equals 5 plus 2x. Alright, well, before I start doing algebra and moving things from one side of the equation to the other, it looks to me like I've got some like terms over here that I can combine and get 2x plus 5 equals 5 plus 2x. And again, if you're paying attention, hopefully you notice that 2x plus 5 on the left side and 5 plus 2x on the right side are in fact the same thing. Well, that means it doesn't matter what number you would put in there for x. This equation is always going to be true. But again, let's say you didn't notice that right now, so you're just going along with your algebra and you say to yourself, well, I got to try to get all the variables on the same side, so I'm going to subtract 2x here and I'm going to subtract 2x here. That cancels out, and I am left with 5 equals 5. Again, positive 2x minus 2x, this cancels out, and you're just left with 5 equals 5. Well, unlike the last problem we did, in which we found a false equation when all the variables canceled out, this time we're left with a true equation. And what that means is that any value of x would make this equation true. So the way we write that answer, and again there are several options, one way is to say all real numbers. But most people don't like to write all that out if they can avoid it, so you can just use this fancy R, and that stands for all real numbers. Now, depending on your teacher, some people like to put this inside a set of brackets to say that the solution set is all real numbers, and there are in fact many other ways to write this solution as well. But the general idea here is that if you go to solve an equation, all the variables drop out, and you're left with a true equation. That means x could have been any real number. But if you go to solve an equation, and you do all legal algebra, and you end up with a false equation once the variables have dropped out, that means that equation has no real solution, or you can represent that as the empty set.